Welcome to our YouTube channel MAST, Mathematics and Statistics. Today we'll be discussing about a very important topic of algebra, which is log. Logarithm will be interspersed into 3 or 4 episodes. Today we'll be learning about the basic formulas associated with log and the basic sums associated with log. In the next few episodes, we will also be discussing about the proving as well as the higher level JE and competitive level logarithmic sums. Please stay with us, subscribe to our channel and share it amongst your friends and well-wishers and help us grow. Thank you. First, let us introduce ourselves to the concept of base of a logarithm. We know 2 to the power 7 equals to 128. Now if we write it in terms of log, we can write log 128 base 2 equals to 7. So in log, we are expressing one number in terms of the other number. So this is our base. Normally in sums, we have either a base of 10 or a natural base of e. At first, we'll be discussing about the different properties of logarithm. If m to the power n equals to p, then log p base m is equals to n. Similarly, if log p base m equals to n, then m to the power n can be written as p. Now we come to the product rule, which is log p cube base m can be written as log p base m plus log q base m. Now the quotient rule, log p by q base m can be written as log p base m minus log q base m. Then the power rule, log p to the power q base m is equals to q comes in front, log p base m. Then log p base q into log q base r can be written as log p base r. Then if you have the same number and the base, that is log m base m, then you get it as 1. This formula does not hold if m is equals to 0 and 1. Similarly, log 1 base m is equals to 0 if m is not equals to 0 and not equals to infinity. The ninth formula, log 0 base a is equals to infinity when a lies between 0 to 1, and log 0 base a is equals to minus infinity when a is greater than 1. So these are the formulas which we will be needing while we solve the problems. The first sum is to evaluate. Now let us start off with the first part, which is log 10,000 base 10. This can be written as log 10 to the power 4 base 10, which can also be written as 4 log 10 base 10. This comes from the formula log p to the power q base m equals to q log p base m. So this will become 4 into 1, which is 4. Why? Because we know log m base m is equals to 1. So the answer of log 10,000 base 10 would be 4. Moving on. Log 27 base 3. Similar to the last sum, let us write 27 as 3 cube, because 3 cube is 27. So from there we will get 3 log 3 base 3. Log 3 base 3 will become 1, so we will have 3 into 1. So the answer for the second part will become 3. coming back to the third sum, which is log 27 base 9. Now while solving these kind of sums, we would try to take the number that we have here in terms of the base. So we will write 27 as 9 to the power 3 by 2. Why are we writing this? Because 9 to the power 3 by 2 means 9 to the power half to the power 3. So that means 3 to the power 3, that is 27. So 27 can be written as 9 to the power 3 by 2. What is the significance of writing it like this? Because now the number and the base becomes the same. So if we take the power in front, we can write it as log 9 base 9, which will equate to 1. So the answer will become 3 by 2. So while solving these sums, our main objective should be to have this number in terms of the base so that we can equate and bring it to 1. Similarly, for the fourth sum, log 25 base root 5. Now, this can be written as log root 5 to the power 4. Why root 5 to the power 4? Because root 5 square is 5 and 5 square is 25. So root 5 to the power 4 by root 5, which is in the base. So we will have 4 log root 5, and here also we will have root 5. So the answer will become 4. Moving on to sum number 5. Log 8 base 0.5. So this can be written as log 1 by 2 to the power minus 3 base 0.5, or log 0.5 to the power minus 3 base being 0.5, which is minus 3 log 0.5 base again being 0.5. So the answer would be minus 3. So for the fifth sum, we get the answer as minus 3. Now for the sixth sum, log fifth root of 10 base 10, which can be written as log 10 to the power 1 by 5 base 10, which can be written as 1 by 5 log 10 base 10, which can be written as 1 by 5, which will be the answer for the sixth part. Moving on to the next type of sums. Here we have exponential forms which we need to convert to logarithmic forms. So let us see how to do them. The first sum is 5 to the power 4 equals to 625. When we apply log, we will have log 625 base 5 equals to 4. So 625 base 5 equals to 4. Similarly, part 2, log 9 base 3 is equals to 2. Similarly, part 3, log 0.01 base 10 equals to minus 2. Moving on, part 4, log z base x is equals to y. Part 5, log 1 by 9 base 3 is equals to minus 2. Part 6, log a base 3 is equals to b. Part 7. Log 1 by 625 base 5 equals to minus 4. And part 8. Log 5.54 base 10 is equals to 0.7435. Moving on to the next type of sums, find x if. So in these kind of sums, we have been given logarithmic terms. We need to first convert them into exponential forms to get the answer. So x would be equals to 5 cube, which is 125. In the second sum, the base to the power 2, so it will be 100. In the third sum, since x is at the base, so we will have x to the power 10 is equals to 1024, and we know x to the power 10, 1024 is 2 to the power 10, so x would be representing 2. In the fourth sum, similarly, x to the power 4 would be equals to 81, implies x to the power 4 is equals to 3 to the power 4, implies x equals to 3. In the fifth sum, we will have x as 5 to the power 4, since 5 is at the base, so x equals to 625. And in the sixth sum, we will have x equals to 3 was at the base, so 3 to the power